Okay, good morning, everyone. Glad to see you on another beautiful day. So today we're going to talk about arithmetic and what does inverse operation mean and integers, and that's it. This is a review from previous math years, like 6th grade and 5th grade. So we're going to go over like real quick because we will need this when we start talking about next lesson. Okay, so let's go now objective. So this is the goal that we need to do today. I can add and subtract numbers on a number line. I know we can add the numbers and subtract numbers like using a calculator or like mentally, but I'm not sure if you're familiar with using a number line. Not yet. Okay, so that means like today we're gonna practice a little bit about how to do that. So you already finished do now, and we're gonna move on. Let's talk about now arithmetic. The arithmetic is basically the 4 operations. We know already that we have a numbers. When we have a numbers, we need to play with those numbers. And in order to play, we have 4 operations. We need 4 operations. So one of them is addition, the second one is subtraction, and another one is multiplication, and the last one is division. So playing with numbers with these 4 operations called like arithmetic. This is the arithmetic, the definition of the arithmetic, okay? And so when we play with numbers, there are different kind of numbers, and we'll talk about those later, like fractions, decimals, and integers, and all fit in the arithmetic. So the next thing, what is the algebra? Like until today, until 6th grade or beginning of the 7th grade math, you learned arithmetic. And from now on, we're going to start like slowly moving forward to the algebra. Not really into the algebra, but we're going to start being familiar with algebra concepts, okay? So, which means where you are using arithmetic operations with both numbers and variables, so this is the variable comes, instead of just with numbers. So this is the algebra, like not only numbers, we're going to start using variables in math. And therefore, if you know how to use all of the properties of arithmetic correctly, means if you know how to do these 4 operations very well, and algebra will not be difficult. It's very extension of arithmetic. So now let's talk about the essentials of arithmetic. So the first essential is addition and subtraction. We're not really talk about addition and subtraction. We're going to talk about the relation between these two, okay? So the simple mathematical operation is addition. As you know, in the history in the previous classroom, you guys learned like after the invention of numbers, the first invention is addition operation. And then they started to think about like instead of combining objects, what happens if you separate them? And this kind of questions like leads to invent subtraction. So it means like opposite of addition. It's the inverse of addition. We call it subtraction. So 2 operations are inverses if one undoes the other. Like if you do the subtraction, undoing subtraction means addition, or if you're doing addition, undoing addition means subtraction. So these are very oppositely related in that way, okay? So this is the main point, like inverse operation means the opposite of one action, okay? So, and it applies to all mathematics. Like in mathematics, you'll find every single action has like an opposite of something. And we'll talk about those. So each time a marble is dropped in a jar, we're doing addition. And each time if we're removing the marble from a jar, so that means we're doing subtraction. This is an example for those 2 operations. And now let's talk about how to add. This is today's objective, by the way, how to add 2 numbers using number line. So pay attention. So here's the example. It says, let's find the sum of 4 and 5 on a number line. So I highlighted the sum. If you're not familiar with this word, sum means addition. Let me put like plus on the top of it. Okay, oops. Much bolder. So this is an addition. Like basically you need to find like 4 plus 5. We know like as mentally we can say it's 9, but how we can prove it using a number line. So this is how you're going to prove it. You always need to locate the first number. So first number is 4. I'm going to locate this. This is my beginning. I start here. So start here. And add 5 means like you're adding means like you're moving forward to the right side 5 blocks, because it says 5 units. So 1, 2, 3, 4, and 5. This is my destination. So I'm going to put an arrow. So this is my destination. So this, your destination will be the result of addition on the number line. Okay. So this is how you add numbers using on the number line. Give me a second. Let me check the chats because some of you guys have questions. All right, those are the attendance. So we're going to move on now. So this is about adding two numbers using number line. So the next question is a commutative property. Have you ever heard this word? So commutative property is like when you add two numbers, it says switching the order. Switching order, does switching order change the result? Not really. Yes, thank you. So it's not changing the result for addition. So we call this commutative property. So it's okay if you change the order. So let me show you, like, let me prove you using a number line. And let's say a 4 plus 5. So because if the 4 comes first, I need to, I apologize. Because if the 4 comes first, I need to locate the 4 first, because this is my starting point. I'm going to put a dot, like bold dot, and then adding 5. Adding 5 means I need to move 5 units to the right. And final destination is, if you move 5 steps to the right, the final destination is 9. So I'm going to circle that 9. And then let me do the on the other side of this equal sign. Is it gonna result is gonna change? Let's see. So because if the 5 comes first, I need to locate the 5 first. So 5 comes first. I need to locate the 5 first. And the second number is adding 4, means 4 units to the right because of its addition operation. And your final destination again will be 9, which means the result will not change if you switch the order when you add two numbers. Okay? And let's move on. So let's practice inverse operation. And this is also a review from last week. If you guys remember this, it was you guys were doing a demo practice. Like inverse operation means the opposite operation of one thing is done. Okay? So one of them is undoes what is the other does. So this is what I mean. So what would you undo adding 5? Could you guys write it down in the chat box? Let me see a couple responses. What is undoing adding 5? Okay. Yeah, it's going back to 5 times. 5 steps. Yes. So which means it becomes minus 5, right? Not subtracting 5, not adding 5. Perfect. And so another question. What would undo -3? What is the inverse of -3? Perfect. What is the inverse of -3? Could you write it down in the chat box? Perfect. I have couple of them saying 3 plus 3. Both of them are the same thing. Yes, it's a +3 or just 3. And the last one is, what would undo -7? Got it? Oh, remember, it's undoing. What is opposite of -7? You can correct it. Yes, now you correct it. Okay. So it's a +7. Perfect. And thank you. So this is the review from last week. It's just the inverse operation or opposite operation. You can also say it. And now the second thing, the second part of the objective for today is how to subtract two numbers using a number line. And let's do the 9 minus 5 on the number line. Again, so the first number is 9. You need to locate the 9 on the number line. So here is the 9. This is my starting point. Okay. And so the second number is action is subtracting, which means you need to start moving to the left side. And second number is 5, means you need to move to the left, to the back, 5 steps. 3, 4, and 5. Your final destination will tell you the result of this problem. So it's going to become 4. Okay, this is how you subtract two numbers using number line. All right, and we're going to do practice for this one. Let's clear out. So the question is, do we need more numbers? You said we need more numbers. So until today, we guys learned what is a counting number and what is a whole numbers. And now we're talking about, like, do we need more numbers? Because of the invention of subtraction, we started to ask ourselves, like, what happens? The question is, what happens if you subtract bigger number from smaller number? So this kind of problems or this kind of questions leads a lot of people to think about, we need like more numbers to represent the result, to find out the result. So, and the result of this kind of questions leads people like think about, like, we need more numbers on the other side of the line. For example, if we are trying to subtract these two numbers on the number line, you will see that there is no result, or you cannot go more step on the back. Let me show you. For example, the first number is 4. And if I locate the 4 on the number line, and action is subtracting, means I'm gonna start moving to the backward 7 steps, because I need to subtract 7. So 1, 2, 3, 4. And because of there is no step to move back, we need something to this side, okay? And that leads us to negative numbers. We need to come up with negative numbers. So there is no answer to question like this, like in 500 years ago, until 500 years ago. And that question led to a lot of people to think about, we need to invent negative numbers. And the negative numbers actually invented 500 years ago, but it accepted 200 years ago. Like it took like 300 years to accept, okay, to agree everybody, okay, we have negative numbers. As you see, negative numbers is invented only 200 years ago, not too in the back in the history. It's very close. Okay, so sometimes this is kind of joke, but if you have a problem with negative numbers, so don't worry about it. Most of us have a problem, and like that. So the invention of negative numbers, we added the group of numbers, like if you remember from yesterday, like the numbers were starting at 0 to forever, and now we're adding on the left side like -1, -2, -3, and to the left side to forever. So this group of numbers, we call it integers. Okay, this is how integers are invented after the negative numbers come. And we call like negative numbers, positive numbers, and 0 all together integer numbers. Okay, this is how you remember. Positive and negative and 0, all numbers we called integers. And at the same thing like yesterday, these 3 dots tells you that these numbers goes forever. For example, I didn't put like -4, -5, -6. It goes like -100, -200, and so on. The same thing for the right side. Because of the numbers on the left side and on the right side, it goes forever. There is no largest number and no smallest number for integers. So you cannot say the smallest integer number is negative something, because it goes forever. You cannot tell them smallest and the largest. Okay, this is the fact, the key facts about integers. You may remember from last year. And number line looks like this. And we were only seeing like 0 to positive numbers. And if you put the line on the left side with the red color, that means like these are the numbers, negative numbers you can see on the number line. Left side negative, right side positive, and middle is 0. Okay. And let's practice it together now. Please, I'm going to check the chat box. I'm going to check the chat box. So I'll ask the question. You guys can respond on the chat box. So the first thing, which of the following is an example of integer? You can type in the chat box saying A, B, C. What do you think? Is -8 is integer? Is -4.5 is integer? Or 1/3 is integer? I have a couple answers. Yes, you're right. It's a -8 because the B is decimal and C is fraction. So only -8 is integer. Okay. So if you're ready, I'm going to ask you the second one now. Thank you so much. I'm still seeing your responses. Yes, it is a -8 and A. So the second question, which of the following is an example of integer? 0.3333 or -6.1 or 287? What do you think? Yes. Do you think, guys, -6.1 is integer? If you see a dot in the numbers, that means we call it decimals, which means decimals are not integers. So it will be, thank you so much. Yes. So it will be 287. I got a bunch of right answers. Perfect. The next one, it's not about integers. What is the opposite of 25? ABC, which one? Opposite of 25 is 25, or opposite of 25 is 0, or opposite of 25 is -25?
Negative.
Thank you. Yes, it is. Perfect. We have a lot of perfect. And last one is, what is the opposite of 0? Do we know opposite of 0? Yes, opposite of 0, it's 0 itself, because opposite 0 is not neither positive or neither nor negative number. So that's why the 0 is 0 itself, the opposite. Thank you so much. We have a bunch of B's. Perfect. And it's going to get like challenging questions. Just pay attention closely. And what is the opposite of 18? Yes. Yes, it is -18. Okay. And we're going to move on. Thank you so much. Next one. So this is a tricky one. Let's see if you can know this. What is opposite of 18? Let's see who can get this. Opposite of 18. -18, 0, or 18?
18.
Wow, you got it. Perfect. Yes, it is C and it is 18 because it will be the same. If you take like twice of opposite, that means like it cancels each other, right? That's why it becomes itself. Thank you so much. So let's see next question. This time, instead of like verbal form, I asked in a mathematical form, which means like by putting a negative sign in front of it. What is opposite of 9? So this is the like shortest way to say it. Opposite of 9. So every time when you see negative sign, that means like saying opposite of -9. Yes, some of you are kind of saying it's a 9. Yes, it is a 9 because two negatives, as I said over here, two opposites are canceling each other and it becomes like itself. It's the same thing. Two negatives cancels each other, like it disappears, and it becomes just a 9. It's C. Thank you so much. Almost, I mean, everybody got it right. Perfect. You guys got the point now. And the last one, now you can understand this. The same thing, opposite of 12, which is, thank you so much. You're the first one. Thank you. So it will be the same itself again, or you can say two negatives are canceling each other and it will disappear. If you see two negatives, they're going to disappear. So it will be the number itself. Okay. So we're going to move on. Now, this is the challenging question. Let's see if you can do this. If you're ready, 3, 2, 1. So this time opposite of 15, which is 3 times. We have A and C's. Some of you say A, some of you say C. What do you think? A and C, A and C. We have a lot of A and C. So let me clarify this. It's okay making a mistake, as we talked about before. Two negative signs, these are canceling out each other, like cross out. And you have 15 and 1 negative sign left, which means it becomes negative 15. Okay? Every time when you see 2 negatives, just cross them out, because those become positive. And look at it, what is left? You have 1 negative sign left and number 15 left, so it becomes negative 15. Okay, whoever said A, you guys are good, and whoever said C, it's okay. So sometimes we learn from our mistakes. Okay, so both of them are fine. Thank you so much. And some of you corrected your answers. That's great. And so here is the conclusion about seeing multiple negatives in front of the number. So here's the conclusion. Remember, when 2 negatives meet together, becomes positive. For example, like negative and negative, in front of 9, there is a 2 negative signs, like outside of parentheses, so they become 9. In front of negative 12, if you see another negative, 2 negative becomes positive, so it becomes 12. So if your name is Thinky and in front of your name you have negative sign, and outside of parentheses you have another negative sign, those 2 negative signs cancel each other and your name becomes just itself, Thinky. Okay, so let's move on. Let's see what we have on the next. Yay, it's a today it's an independent practice. So I'm gonna come back this later. So let's recap first. So arithmetic is the 4 operation, like adding, subtracting, multiplying, and dividing with all types of numbers, not only integers, not only decimals, it's all types of numbers. So we call this arithmetic, and we practiced until today a lot of arithmetic, okay? And the second thing we talk about is inverse operation, or let's say opposite of addition is subtraction, and opposite of subtraction is addition. So they each one of them is undoes the other one, okay? So this is the today's lesson, and the last thing you're gonna do is if you listen to this lesson, you need to take your time to reflect what you learned for today and write one thing that you learned from this lesson. Could be the knowledge that you already know it, but you remember it again, that's also fine. Or if you learn something new, you can also write it down, okay? So here's the exit ticket. You just need to click it. It'll take you on a new window, and it's only 2 questions. That's it. It's that much simple, okay? And about UDO, this is the independent part. After this, you don't have to stay in the Zoom session. You can leave. So you're gonna go on your IXL, okay? And you're gonna find B1. We practiced this, how to find the assigned skills on IXL. And I want you to like try your best. If you cannot reach this score, just still let me know. We will do something about that, okay? So try to get 70 score or above. And you can also find this assignment on the classwork tab. And by the way, once you finish B1, you need to turn in on the Google Classroom. Okay, that's it. So somebody is raising your hand now. I'm going to